There's a specific color of light coming off Pluto that has never been seen anywhere else in the known universe. Not on any planet, not on any moon, not on any exoplanet astronomers have ever cataloged anywhere, in any solar system we've been able to study. And the James Webb Space Telescope only just found it, because until recently, nobody had the right instrument pointed at Pluto in the right way to even notice it was missing. Everybody, we need to talk about what James Webb just did to Pluto, because shouldn't be possible is not clickbait here. It's the actual published, peer-reviewed reaction of the scientists who ran this data. For nearly a century, Pluto has been treated like the small, frozen afterthought of the solar system. A dwarf planet, demoted, distant, mostly ice and rock, orbiting so far from the sun that sunlight there is roughly 1,000 times dimmer than it is here on Earth. That was the story. That was the assumption. James Webb just broke it in two completely different ways within the same set of observations. Let's start with why this observation even needed to happen, because the answer says a lot about how much of the universe we still haven't actually looked at properly. Pluto was discovered in 1930 by American astronomer Clyde Tombaugh, and for the next 85 years, humanity's understanding of it barely moved past a fuzzy dot in a telescope. That changed in July 2015 when NASA's New Horizons spacecraft screamed past Pluto at more than 30,000 miles per hour, passing just 11,095 kilometers from its surface and sending back the first close-up images anyone had ever seen. New Horizons revealed a world nobody expected: towering mountains of water ice, glaciers made of nitrogen and methane, a geologically active surface with basins, valleys, and a massive heart-shaped plain that instantly became one of the most iconic images in modern astronomy. Pluto, it turned out, wasn't a dead rock. It was alive in every geological sense of the word. But New Horizons had a problem. It was a flyby mission, meaning it had one shot, one pass, moving too fast to linger. And critically, it didn't carry the kind of instrument that could break Pluto's extremely faint light down into the specific wavelength range. Scientists needed to really understand its atmosphere and its haze. That gap sat unresolved for years, an entire category of Pluto's behavior that nobody had the sensitivity to actually measure. Enter the James Webb Space Telescope. Webb carries an instrument called MIRI, the mid-infrared instrument, built specifically to detect exactly the wavelengths that had been out of reach for every mission that came before it. In 2022, and again in more detailed follow-up observations, an international team led by researchers from the CNRS, the Paris Observatory, and the University of Reims finally pointed Webb's MIRI instrument directly at the Pluto-Charon system. And for the first time in the history of astronomy, scientists obtained a high-quality mid-infrared spectrum of Pluto, spanning a range of wavelengths that had simply never been explored for this world before. That's the literal first half of this story. James Webb didn't just look at Pluto again. It looked at Pluto in a way nothing else in human history had been capable of. What it found first confirmed something scientists had only theorized about for almost a decade, and it turned out to be even stranger than the theory predicted. Back in 2017, planetary scientist Shi Zhang at the University of California, Santa Cruz, led a team that made a bold prediction about Pluto's atmosphere, specifically about the thin layer of haze that sits high above its surface. That haze is made of complex organic molecules, created when sunlight triggers chemical reactions in the methane and nitrogen gas surrounding Pluto. Zhang's team proposed something that, at the time, sounded almost too elegant to be true. They suggested this haze wasn't just a cosmetic feature, a bit of atmospheric fog drifting above the ice. They proposed the haze was actually running Pluto's entire climate system, absorbing sunlight during Pluto's day and radiating that heat back out into space as infrared energy at night, cooling the atmosphere far more efficiently than ordinary gases ever could on their own. If true, that would make Pluto's atmosphere behave completely unlike any other atmosphere in the solar system. Powered not by gas dynamics the way Earth's or Mars's atmospheres are, but by solid haze particles acting almost like a planetary scale thermostat. It was a genuinely radical idea, and in 2017 there was no way to test it. The instrument that could confirm it didn't exist yet. That instrument arrived in the form of James Webb. And when scientists finally pointed MIRI at Pluto and separated its faint signal from Charon's, the data matched Zhang's decade-old prediction almost perfectly. Pluto's haze really was glowing exactly the way the models said it should in the mid-infrared, precisely the signature you'd expect if that haze truly was absorbing and radiating heat as the dominant force controlling the entire atmosphere. Zhang's own reaction, on record, tells you how rare this actually is in planetary science. He said it's not common to have a hypothesis confirmed so quickly within just a few years, and that his team felt lucky and genuinely excited. Tanguy Bertrand, the astronomer at the Paris Observatory who led the newer analysis, described exactly what this makes Pluto. He called it a new kind of climate, unique in the entire solar system. Think about what that actually means. Every other planet and moon we've ever studied, has its climate driven primarily by gases, Pluto is being run by solid haze particles instead, an entirely different physical mechanism for regulating temperature that doesn't exist anywhere else we've looked. That alone would have been a headline-worthy discovery on its own. It is not, however, the strangest thing James Webb found. Buried in that same high-resolution spectral data at a razor-specific wavelength of about 11 micrometers, scientists found something missing. A dip in the light, an absorption line, meaning something on Pluto's surface is soaking up light at that exact wavelength, the same way every known chemical compound leaves its own unique fingerprint in a spectrum. Except when researchers searched the literature for every known ice, gas, and organic compound ever cataloged in Titan's or Pluto's atmospheres, ethane, ethylene, acetylene, propane, benzene, hydrogen cyanide, none of them matched. The researchers wrote plainly in their paper that they did not find any previously documented band that corresponds to the location of this absorption. In plain language, something on the surface of Pluto is made of a chemical compound that has never been identified anywhere else in the universe. And here's where it gets genuinely bizarre, because this same unexplained signal wasn't unique to Pluto. Scientists found the exact same 11 micrometer absorption line on Saturn's giant moon Titan, an object that has almost nothing in common with Pluto beyond both having nitrogen and methane-based atmospheres. Titan is a moon locked in orbit around a gas giant with a thick, hazy atmosphere and a surface pressure about 50 times greater than Earth's, complete with actual liquid rivers and lakes, the only other place in the solar system besides Earth known to have stable liquid on its surface. Pluto is a frozen dwarf planet, roughly half Titan size, sitting in the isolation of the Kuiper Belt, 4 times farther from the Sun than Titan even gets. 2 worlds with almost nothing in common, in completely different regions of the solar system, both showing the exact same fingerprint of an unidentified molecule. Researchers ran a careful check to make sure they weren't just seeing some kind of atmospheric interference contaminating the signal. If the absorption were coming from gas in the atmosphere, rather than something solid on the surface, it should appear stronger toward the edge of each world's visible disk, where light has to travel through more atmosphere to reach the telescope. Instead, they found the opposite. The signal was actually weaker at the edges and stronger toward the center, which is exactly the pattern you'd expect if the absorption is coming from something sitting directly on the surface itself, not floating in the air above it. The 2 signals aren't even identical, and that difference might be the biggest clue of all. On Pluto, the absorption line is roughly 3 times wider than the one found on Titan, even though both dip to a similar depth in the spectrum, somewhere between 4 and 5%. A wider absorption line like that usually points to something about the physical environment the molecule is sitting in, not necessarily a different chemical altogether. Researchers considered whether Pluto's much colder surface temperature, somewhere between 30 and 60 degrees above absolute zero compared to Titan's 90 to 95, could explain the difference. It couldn't. Colder ice typically produces narrower absorption bands, not wider ones, so temperature alone runs backward from what they actually observed. The leading explanation researchers are now investigating involves something almost nobody thinks about when they picture Pluto sitting quietly at the edge of the solar system, cosmic radiation. Pluto's atmosphere is far thinner than Titan's, meaning it offers far less shielding. Streams of high-energy cosmic ray particles from deep space can punch straight through the thin atmosphere and bombard Pluto's surface ice directly, penetrating anywhere from several centimeters to tens of centimeters deep, chemically altering whatever compound is producing this signal in ways that could physically widen its spectral fingerprint. Titan's dramatically thicker atmosphere would shield its surface from that same bombardment almost entirely. If that theory holds up, the compound itself might genuinely be the same molecule on both worlds, just weathered by 2 completely different radiation environments into 2 slightly different versions of the same chemical signature. As for what the molecule actually is, researchers have narrowed it down to a short list of genuine suspects without landing on a confirmed answer. Among the leading candidates are allenes, a class of organic compounds known to absorb light in a very similar part of the spectrum. Benzene, mixed with other molecular species, is also on the table. So is ketene, along with certain compounds that form specifically when methanol ice gets irradiated over long periods. Exactly the kind of slow chemical transformation you'd expect billions of years of sunlight and cosmic rays to produce on a surface this ancient. But to be clear about where the science actually stands right now, this discovery was only uploaded to the preprint server arXiv in June 2026 and has not yet completed peer review. The researchers themselves are careful to say much more work is needed before any of these candidate molecules can be confirmed. If you want to see where the peer-reviewed follow-up on this actually lands, subscribe now, because a discovery like this, an unidentified compound showing up on two completely unrelated worlds, is exactly the kind of story that gets a confirmed answer within the next year or two, and we'll have it the moment it drops. So here's where that leaves us, and why it shouldn't be possible isn't an exaggeration for a video title. James Webb pointed a mid-infrared instrument at a tiny frozen world 4 billion miles from the sun for the first time in the history of astronomy. And it didn't just confirm one landmark hypothesis about how Pluto's climate works. It also, in the same sweep of data, stumbled onto a chemical signature that doesn't match anything in the entire known catalog of solar system chemistry, sitting on the surface of two worlds that have almost nothing else in common. That's not one discovery, that's two layered directly on top of each other. From a single set of observations of a planet, most people stopped thinking about the moment it got demoted from the official planet list back in 2006. Pluto was never actually boring. It just took us nearly a century, one flyby spacecraft and one telescope orbiting 1 million miles from Earth to finally have the tools capable of proving it. Somewhere on that frozen, haze-covered surface right now sits a compound nobody on this planet has ever formally identified, quietly absorbing a very specific color of light that scientists are still racing to explain. If stories like this, real published science, real unresolved mysteries, and zero exaggeration are what you come here for, subscribe and turn on notifications, because between the confirmed haze discovery and whatever this new molecule turns out to be, Pluto is nowhere near finished surprising us.